Okay, let's get started with chapter 9.2. And one of the things I'd be interested in is, well, what's the difference between 9.1 and 9.2? So in this case, we're going to have two populations. Okay, and the difference would be is in here we're measuring averages. And to measure averages, we want quantitative data. So last chapter it was always like yes/no situations. They would count successes. So in this case, we're getting like real number-based data. Now, this is going to be for 9.2 and this is 9.3. So what two samples independent means is that when you have this first sample and you have this second sample, because we have two samples, the people in here, or the objects in here, cannot be related at all. They're not related. So if you're like, hey, that person's from the first sample, and this person's from the second sample. And let's say we measured this person's blood pressure. And remember, he's from the first sample. This person's from the second sample. Let's say we measure his blood pressure and it's high. Now, since this guy or girl that has nothing to do with this guy or girl, they're not related. Meaning that if you know they have high blood pressure, does that have any effect here on this person over here? And that's no. So they're not related, so they're not independent. Independent means if you know like this person's high, then that would give you some insight on this person. Now what if you measured their blood pressure and then had them come back in a week? So you were saying, okay, well, let's get the blood pressure. Now this is you. This is week 1 or first week. Let's say, hey, it came out high. Hey, you had high blood pressure. Now 1 week later, you come back in. Now before you take the blood pressure, do you have some sort of expectation on the level of the blood pressure? And I would say, yeah. Well, if it was high then, I would expect it to be high here. And it'd be like, well, why? Because it's the same person. So since it's the same person, they're not independent, they're dependent. So whenever you measure stuff whenever you measure values on the same person, that'll be a test that we're going to learn in 9.3 and not 9.2. We're going to do both of them here. Okay, so here's our notations. Okay, so the population mean, if it's a population, is a mu1, since it's from the first population. Size of the sample, that doesn't change, n1. Sample mean, this is different. That's an x with a line over it with a 1. Sample standard deviation, that's s with a 1. All these are going to be the same with the 2. Okay, these are going to be really important. Now remember, just as a review for StatCrunch, if you ever get a test that's dealing with mu's, you have to pay attention. It might be a z-stat or a t-stat. Now this one's more popular, and this is when we're using s. We use this one if we're using sigma. Okay, most of the time we don't know sigma. Most of the time it's unknown, so we're using s. Okay, we have two ways to do this. We could use the p-value method or the confidence interval method. We'll kind of do both of them. Okay, so if you'd like, you could pause the video. Okay, so let's get started. So men and women are equal talkers. Here's your claim that men have the same mean number of words. So since it's the same mean, that the mean of the men is equal to the mean of the women. That's our claim. So whenever the claim is an equal and our null, it's going to be an equal. And the test is trying to find evidence that they're somehow different. And this is like a mu or a u. Okay, so now we're going to have to run the test. So when I run the test, I have to say something like, hey, are we using S or are we using sigma? Remember, this is the population SD. This is the sample SD. Okay, and right here we are using S's. So we're going to use a t-stat. When we run t-stat, it's going to give us a t-score. To sample, we don't have the data, but we have a summary of the data. Okay, same thing here. I'm going to put the men's data in first. So sample mean would be this number here, 1, 5. Sample standard deviation would be 8632. And the sample size will be 186. Okay, next sample mean, 16215. Seven 301.2, and the sample size here is 210. So let's see. Guys were 15,000, girls were 16,000. On a relative medium sample sizes with a pretty large standard deviation. That doesn't seem to be too significant just by looking, but let's go see here. Now this needs to match your null, this down here, and I'm over on this side over here on the right. This needs to meet your alternative. So we're all set up to go. And compute. Okay, so I got a T of I'll just say 0.68. Get a p-value of 0.4998. My alpha is 0.05. That's right here. Let me show you. That's right here. Now decision, we have to compare the p-value, which is 0.4998, to the significance level. That's greater. So this is going to be a fail to reject. That's your decision. Whenever you fail to reject, try not to talk about this. Don't talk about this, talk about that. Sorry. Don't talk about your null, talk about your alternative. So we want to be talking about, this is what I'm going to be talking about. And this would be, we have no sufficient evidence that, now I'm just copying over what they wrote, I'm writing this, that men and women speak the same mean number of words per day. Okay, so that's how you do that one. Now let's do a follow-up confidence interval. Step 1 is going to be the same. Now we have to make a decision whether we think it's a one tail or a two tail, and I'm going to go with two tail because this over here is not equal to. If it's a two tail, we use this formula, 1 minus the significance level, which was 0.05. If you do this in your calculator or your head, you'll get 0.95. We're going to go back and so I don't have to put the data all in again. I hit options, edit, all the data is in already. Change from confidence level, that 0.95. And the same idea goes, I'm looking for a 0 in the interval. So my lower is my lower and my upper from over here. Is 0 in there? 0 is in the interval. So that's going to be a fail, 2, reject. So your interval goes from negative 2, 1, 3, 7. And here's 0. So 0 is in the interval. So what that means is that if 0 is in the interval, then mu m minus mu w could possibly be 0. Doesn't mean it is 0, it means it could possibly 0, which means that the test did not find enough evidence to say that they're different. Okay, so this is going to be the same conclusion. So the conclusions will be the same. So if you fail to reject up here, you should be seeing 0 in here. If you reject up here, you should not be seeing 0. Okay, so let's look how a paired test runs. So a paired test is essentially if the data is on the same person. Okay, so you have the right arm and the left arm. And we're measuring the blood pressure, the systolic. Now, if you notice, this is the same person 5 different times. Well, look at all these. These are a lot lower. Okay, but let's look at the claim. The claim is that there is a difference. So the claim is that the mu of the right is somehow not equal to the mu of the left. So that's going to go on my alternative. So my null is going to be that they're the same. Okay, so I'm going to go ahead and pause the video and put the data in. Okay, let's get started with how to do a paired test. So it's kind of scanned down here, looked at this problem already, but we're doing paired data. So paired data means that we're going to get 2 measurements on the same person, or 2 measurements on 2 people that are like related very, so you can see the relationship pretty easily. Now this test is just done differently than the 2 sample. We don't look at it as a 2 sample. What we do is, I'm over here right now. So let's say the first data set, I'll use this example. So the first data here is the right arm, and this is 102. So read this question. They took these 2 measurements on the same person. So on the left arm, the person got a 175. Okay, the next time on this person was a 101 versus a 169. So, etc. Now, what we do is we see how different they are. So we do 102 minus 175. So her right arm was minus 73. Was minus 73. So the blood pressure was 73 less on the right arm. We do the same thing with the next one. And we get a minus 68. So the second time she did it, her right arm was 68 less than her left arm. And we do that 5 different times, and then we test from this list. But this list is called a differences list. So we should only have 1 mean. So there's only 1 mu. We call that mu difference, not 2 mu's, like we just did with 9.2. So your null would be, it says, okay, was there a difference? So you'd say mu d. This means that this means that there is a difference. There is a difference. Well, if there was a difference, mu d would not be equal to 0, which would mean mu d is not these 5. Mu d is all differences. These 5 are just a subset, just a sample. This would be all of them. This one. would be from all times that she would check. Okay, so remember, this is a not equal to. The not equal to will go in your alternative, and your null will be equal to. Okay, now to run the test, you have to put the data into your calculator or into StatCrunch, which I've done. Let me finish erasing this. Let's do it this way. And once you put the data in, it'll just basically do it for you. So when you hit stat, this is going to be a t-stat again. Now 1 sample 2, this is paired because the person's paired with themselves. Okay, so the first variable, that's the left, or sorry, right. Second is that one. Keep these the same. And we get a t-score of negative 17.34. We get a p-value of 0. We get an alpha here of 0.01. So we are going to go ahead and 0 is less than 0.01. We're going to go ahead and reject the null. That reject should be up here actually. We reject the null. That means that I'm rejecting this. So if I reject this, then I have evidence for that. And what this says is that there is a difference. Okay, so we have sufficient evidence that there is a difference between, and I just write this thing out. Okay, now same thing as we've been doing on all these things. You could do a confidence interval, follow-up confidence interval, and you could do this. Boom. Okay, so how many tails? This is a two-tailed. So I have to use this one, 1 minus 0.01. So that's a 0.99. When I get my interval, try to see if you could figure out if 0 should be in the interval. We rejected the null. So if to reject the null, question mark, should 0 be here? Okay, so see if you could answer that. You should know, but if not, you could wait and see. So now what I'm going to do is do edit. All my data is in already. I need to change this to a 0.99. Oh, I got to select on it first. Oops. 0.99. Okay. And let's see if 0 is there. So I go from a negative to a negative. So 0 is not there. Negative 91 to negative 53. So there's your interval. So 0's not in the interval. So this should be a reject H null, which is the same thing we did up here. It's the same decision. And this conclusion is the same. We have strong evidence that her left arm is not the same as her right arm. I mean, it's kind of obvious. Okay, let's do another example. Okay, so this is a diet question where, and we get these on the same page. So. Now what makes this a paired test and not a two sample test is this is the same person and there's two measurements. This person lost 7 pounds. This person looks like they lost 9 pounds, 2 pounds. This person gained 5 pounds, that's -5, etc. So we're studying this list. That's the list we study. Okay, so this is a paired t-test. And let's see what we have going on here. If there's a claim, the claim that the dye is effective. Well, if the dye is effective, this should be lower. So if you do before minus after, the after should be smaller. That should be smaller if it's effective. Well, if that's smaller, you'd get a number greater than 0. If you ever take a number that's larger and subtract a number that's smaller, you should end up with a positive number, like 6 minus 4 gives you 2. Okay? So the claim is that mu d is greater than 0. So here, mu d is greater than 0. Here, mu d is equal to 0. So this means not effective, and this means effective. Now, just if everybody here lost weight, that still doesn't make it effective. The weight loss from each person has to be pretty significant for the test to reject this null. Okay, so now we're going to go ahead and run the test. To run the test, we need to put the data in. So I'm going to put the data in real quick. Okay, so I have my data in. And to run the test, this is going to be a t-test. And just that. T-test, and then we want to make sure we go paired here. Paired. The data is paired because we have 2 measurements on the same person. We don't have like 2 different groups that are independent. Okay, I mean, we have 2 different groups of data, but each data is about the same person. Okay, so we want to go, that's going to be the before, that's going to be the after. I'm going to change this to a greater than sign. That should match that. Now you have to make sure to put your before in first and your after in second, so it'll switch around. And this will run the test. So 1.95. So that's a t. That's your test statistic. Your p-values 0.0493. And we're using an alpha of 0.01. So we have to compare this to this, and that's that whole thing with if the p is low, the null must go. If the p is high, the null will fly. And this time that's bigger, so the null will fly here. So this is a fail to reject. Okay, so we're not rejecting this. So that means we don't have evidence for this. So we have insufficient evidence that the diet was effective. Okay. All right, so that's how you do a paired test. You guys got to look at a couple of those. Let's see if there's anything else down here. Okay, and that's it. So I'll go ahead and do the homework and have that posted, which should help out also of running through these tests. So thanks for watching. Hopefully it was helpful.